How can a particle cross a barrier it doesn't have enough energy to climb, without cheating energy conservation? In the energy filament theory, a barrier is a tension wall, a fine thickness breathing band in the energy sea that is usually closed yet briefly forms pore corridors. So tunneling is catching and opening rather than breaking rules. Textbooks often say the wave function has a tail, which is true and also the least cinematic explanation ever. Then they whisper about imaginary momentum and move on, as if the wall is just a symbol on paper. Eft insists the wall is a physical state of the medium, not a magical prohibition line. A tension wall is a region where the sea is tightened, connectivity is reduced, and coupling becomes picky. That means not enough energy is not a moral judgment. It's a statement about how rarely the medium offers a compatible route at that moment. Zoom in and the wall behaves like a door made of fast Venetian blinds in gusty wind. Most of the time the slats don't line up, so the corridor is closed and reflection wins. But the energy sea is never perfectly still. Under microscopic agitation and tension background noise TBN, tiny low-resistance pores flicker open and shut inside the wall. If a short chain of those pores happens to connect across the band, a passage exists for a moment, and a coherent wave packet can slip through. No energy is borrowed from nowhere here. The medium is doing micro-unk work as it breathes, and the accounting stays local in the wall's own fluctuations. That picture immediately explains why tunneling is rare but not impossible, and why it depends so brutally on barrier thickness and height. Make the walls thicker and you need more layers to align at once, which multiplies the rarity. So the transmission drops almost exponentially. Make the wall taller by tightening it harder and the pores become rarer, shorter-lived, and more selective about direction, so the odds collapse again. You can think of 4 knobs hiding inside one probability: how often pores appear, how long they survive, how picky they are about direction and phase, and how well a pore at one depth can connect to a pore deeper inside. Stacked rarity is not mysticism, it is just 5 doors in a row being harder than one door. This is why an STDM current collapses when the tip moves a hair, and why nuclear lifetimes can swing wildly with tiny structural shifts in the barrier region. Now the time question: is tunneling instant? Only if you start the stopwatch after the door has already opened. The real process has 2 timescales: waiting for a corridor to appear and then crossing it. Crossing is quick. Waiting can be long and noisy, which is why tunneling time debates get so confusing. So the headline superluminal tunneling is usually people timing the jump, not the long queue at the gate. And nothing is free while you wait. The barrier region can still exchange energy and information with the environment, reshaping the odds run by run. Punchlines: walls breathing, pores flickering, and tunneling is the art of arriving during an opening. Next, resonant tunneling, where adding structure can sometimes make passage easier instead of harder. Tap follow, share it on New Physics, Clear Universe.